Hey everyone. So welcome to the space. Today's every Friday we have the space every Friday from 3 to 4 p.m. Eastern, not yeah, Eastern time. Eastern time. Sorry. Uh, and we feature different speakers, different topics. So if there's ever a speaker or a topic that you want to be featured, if you would like to lead a talk yourself, just DM any one of us, and we'll be sure to get you on the schedule. Today we're talking about why bad code exists with Jeff Langr and Tim Ottinger. If you would like to ask one of the main speakers a question, or if you would like to just contribute a thought, use the emoji icon at the bottom of your screen, or use the press the heart icon at the bottom of your screen to raise your hand, and Mandeep or myself will bring you up as a speaker, and then you can just go ahead and ask your question. We just encourage a healthy dialogue, sharing lots of insightful ideas, and just a generally respectful space. And we haven't had any issue with that up until this point. So looking forward to today's conversation.
Yeah, so as we build up our audience, we'll start in a couple of minutes.
I wanted to say hi to Kevin. How you doing, Kevin? Long time no see. And happy to welcome Troy to the group. And John Reed. Hey, John.
Yo. All sorts of friendly faces.
So as we get started, Tim and Jeff, do you all want to take like a minute to just kind of introduce yourselves and kind of let everyone know a little bit about your background, what you do now, and kind of how you got to this place where you wanted to discuss this topic?
Sure thing. Tim, go for
it. What did I know that you were going to defer? So, hi, I'm Tim Ottinger. I've been a programmer. I started writing code for a living, for income, in 1979. Jeff and I are co-authors of a bunch of different things, including Clean Code. We both were members of that project and that anthology. After 40 some odd years of seeing code that comes out less than ideal, it's kind of interesting to try to understand why that is and try to be helpful. So, Jeff, what do you think?
Pretty much all the same stuff you said, Tim. I mean, we've known each other for about 15 years now. I actually bit a big bullet and decided to come on full time with Industrial Logic. So I'm really excited about working with all the folks there, and particularly since I get to now pester Tim on a more regular basis. So that's really cool.
Yeah, now I have to answer.
Yeah.
Jeff, you can check out anytime you like.
Jeff cannot check out. He has to stay for life.
So Jeff and Tim, both of you have co-authored a bunch of stuff. Why don't you tell us about that a little bit?
Tim mentioned a little bit about, we both contributed to Clean Code. Robert Martin's also put out a book on Clean Agile that we did a chapter in on Agile tools. We've also written piles of articles together. So like for about a year, a couple of years, Tim had some big ideas around software design. So we kind of collaborated on a handful of those and just a smattering of others. So if you go back, and I think Prog is actually making a lot of these articles available now on Medium. So if you go out to Medium and search for the Pragmatic bookshelf or the Pragmatic Programmers, I think, you'll find a bunch of those articles, and they still hold up. I mean, that's the cool thing, is very little of this stuff ends up dating. It's still all relevant. We still apply most of the same stuff today.
Yeah, that goes, all the way back. I've been really surprised. I thought that our stuff would age less gracefully than it has.
I think we already learned that lesson. So we've also collaborated on another big project, Tim and I, about 2011, I think. Actually, no, it was before that. We started doing blog posts around just the notion of Agile related lists. So we would do a different index card with different things, like what are the four values of XP, or what are the 12 principles in Agile, or what are 6 ways to do some kind of refactoring or something like that. So we did all these cards and then put a book together around it. And so, Tim, what else can you add about the Agile in a Flash stuff? I mean, we tried to put one up this morning around this discussion.
Yeah, so it was that was a great experiment in trying to see how quickly you can get a point across and how helpful you can be in the smallest space. And it originally came out as a set of 4x6 cards with a cheat sheet on one side and an explanation on the back. And then later on, they quit printing the cards. So now it's only a
Hey Tim, you're breaking up a little bit. So
So to fill in Tim's thought real quick, yeah, we had these printed up, and then the printer said they couldn't print them anymore. So if you go to Amazon now and try to buy a printed copy, I think they're selling for like $300 or $600 or something really silly like that. You can still get the PDF versions or whatever from the site, but good luck with the printed ones. I probably have a handful left, so if somebody's really nice, maybe I can send them out one. Maybe we'll give out one as a prize somehow. But yeah, we still go to shop. When we were going to shops, I always have to remember pre-COVID. It's been a few decades, I think. We would go out and see people just use the cards in conversation here and there, and then sometimes stick them up on the walls, or tape them to monitors as reminders of things to discuss when building stuff. Tim, are you back?
I'm trying to be back. I'm trying to find a space in my hotel where I have better Wi-Fi.
Oh, that can't be good.
Can you hear me okay?
Fine right now. Yeah, you're absolutely fine.
Okay. Well, I might just sit out here on the steps then.
So guess what I was doing this morning?
Writing index cards?
No, writing bad code. So I think that's the first admission of coding is I think everyone in here has written bad code at some point in their lifetime and probably some point in the past few hours. I think the big distinction is we kind of recognize it, and the more we work with other folks, more we recognize our code is a problem. I mean, code most people write on their own seems fine to them at the moment. So our big distinction is we recognize that, we work with other people and get their feedback, and then we look for ways to make sure it ain't so bad going forward before we push things up.
So how do you define, and each of you could answer differently in case you had different perspectives, but how do you define bad code? Because seems very subjective, right?
Yeah. Tim, start us out. I got a few ideas.
Yeah. So the first thing to do is let's define good code, because, bad code is a negative space, right? So good code is good blue collar working class code. It runs, it gets its thing done. It's fairly obvious. It's unsurprising. It's not high concept and fancy and artisanal, but it's also, not garbage. It's clear, clean, simple, straightforward. That's good code. So bad code tends to be stuff that either doesn't work or doesn't always work, or it's just in such a shape that it's unpleasant to deal with.
Yeah, I'll be simple, and I'll reduce it to pretty much bad code is anything that cost us more than it could if it had been taken a little more attention to. So things that take us longer to understand, we've got to pick up some code to maintain it. What I don't want to be doing is spending 10, 15, 20 minutes trying to wade through the code and figure out what in the world this code even does before I can make my changes to it. So code that is readily expressive and clear and lets the intents be very obvious to anybody picking up this code. That's start of good code. And then obviously once we start wanting to make changes to it, is it a nightmare of a lot of extra work to make the changes? Is it something where every time we touch the code, we find we're breaking something elsewhere in the code? So that's all what we would characterize as bad.
We actually have a card about good code that says what are the good code virtues, and it talks about how it should be working and should be unique and not duplicated. It should be clear, not confusing. It's like 7 different principles, and it's not only on Agile in the Flash, but there's also an article at the Industrial Logic blog that explains the 7 code virtues. And if you look at those, you'll kind of see what good code looks like, and bad code is whatever that isn't.
I had a mentor tell me that companies mistake code as an asset when it's mostly a liability, which might be an overstatement, but it helped me realize that, it's a mix of both.
Yeah, it's sort of like having a really big front yard. It's really nice, but you have to mow it and fertilize it and keep the dogs out of it and manage it and manicure it. And if it gets too long, it runs the neighborhood values down. So it requires constant care. Code has a certain burden.
Yeah, my lawn is a liability.
Yeah, it's something.
And the other distinction that I'd pair with John's, that code is a liability rather than an asset, is that code is not for computers; it's for people. And maybe that's already assumed in this discussion, but I kind of wanted to put it out there because I think a lot of people who end up making what we're identifying as bad code are thinking, well, that's just for the computer, and it's my job as a developer to manage that, not to make it better for other humans.
That's a great point. And I want to ask a follow-up question to that. Before I do, I just want to send a reminder to anyone that's listening. If you wanted to join the stage and ask a question directly yourself or just add a thought or comment, please request to speak and myself or one of the other co-hosts will move you up. So John, I wanted to ask about that point that code is for coders and not for computers. How does a team or organizational structure affect that mindset around good and bad code?
Jeff, not John.
Oh, that was Jeff. Sorry. I thought that was John responding. Go ahead.
Wait. Repeat the question then, because I was thinking of something else and thought you were talking to John.
Oh, well, I thought it was John that was saying, good code is for developers. It's for people, not for computers.
Yeah, that was me.
Okay. Yes, I was asking in follow up to that. How does the team and or organizational structure affect that mindset around seeing code that way?
Oh, that's a good one.
Well, here's my take on that. Remember, we tend to think that code is readable or it isn't, and I think that that's unfair to say that about code. Readability isn't an attribute of the code artifact. It's an attribute of the relationship between the artifact and its audience, right? So to a Python programmer, Python code is generally pretty readable. But if you're a Go programmer and you're looking at Python, it may not be so readable. And if you're a non-programmer, it probably doesn't make sense at all. Well, what's that thing there? Well, that's a list comp. Oh, don't you know what a list comp is? Well, no, because I'm not a Python guy. So within an organization, the audiences vary, right? So you may have an organization where one small group of people who work in one small component are the entire audience for one piece of code. But another piece of code has an entirely different audience, and they come up with different shapes.
And to follow up kind of on Jay's question, how do those people then interact if they speak effectively different languages, if they have different relationships to the same code?
Right. And classically, I mean, it's really, we tended to solo for so long and people would stay in their cubes and I think spend copious additional amounts of time trying to figure out what code is doing. Pretty much most of us that are speakers on this call kind of believe nowadays that highly collaborative coding is far more effective for that reason alone, plus a lot of other reasons. So in other words, I think a developer in their cube is going to blow hours and hours and hours wasting time over a typical week or so just trying to figure out what things are going on in the code when they could rather, when you start working in a collaborative environment like pairing or mobbing, the answers come far more quickly. And if there's a question about the code, there's someone to answer the question and clarify what's going on and help make it into something that is more accessible and readable by everyone. So yeah, it's a relation of each and every individual to the code, but once you start getting us all in the same space and discussing this all collaboratively, the higher likelihood there is that we're all going to be on the same page with what's going on here.
Yeah.
So once you know you have bad code, go ahead, Mandeep.
Yeah, so in your blog, both of you kind of addressed 6 top reasons that you think bad code is still exists and is being produced by software development teams. So I was kind of thinking that we can address, each one of them and move through them and basically talk about each one. So the first one that you mentioned there is no continuous review process.
Yeah, and I think Jeff just kind of hit on that. When we work in a collaborative way, ensemble programming, you can call it mob programming, pair programming, whatever. Then you are actually engaging the audience with the artifact while it's being created. And so that continuous review, working in pairs and mobs, ensembles of various types, swarms, that because you're engaging the audience, you're building the code that the audience can use and understand and work with, and that if there's an objection, you hear it, in the act of creating the code, not sometime the next week.
All right.
When you say continuous, what does that mean?
That means as the code is being
how
developed.
frequently?
That's as the code is being developed. So each line of code is being reviewed as it's being typed. Am I coming through okay?
Yep.
No, yeah, you are. In your experience, because I know you've worked with a lot of organizations and a lot of different teams, how common do you think it is to approach to a coach reviewing code that way, with that level of consistency?
Yeah, the history that starts with well before XP, but XP brought about this whole pair programming notion. And I'm going to say there's a lot of developers that have tried it, and a lot of them moved on because they absolutely detested it or hated doing it. We're finding mob programming seems to be a little more palatable, but I have to imagine still the vast majority of developers don't want to be working this way. What we're finding though that's interesting is it's very appealing once you start getting into a group where we all are getting onto the same page with everything, bannering ideas back and forth, coming up with a better way to build software as opposed to each individual figuring out things on their own and wallowing in their own cubes. So what we found is the pair programming definitely rubbed the majority of programmers the wrong way, and I think we're finding mob programming tends not to have that as much of that, maybe because of the intimacy required with pairing that kind of goes away in more of a group dynamic.
And to be fair, I think that a lot of organizations, they expected to hate it, and that's why they abandoned it, right? They don't want to work with some party looking over their shoulder to say, or sit and watch somebody code. So that's not what pair programming is, but people picture it that way, and then they'll try it that way and hate it because that's not what it is. So
Well, then they're going to see that I wrote bad code.
Yeah, that's right. And if you go back and look at Pair Programming Illuminated by Williams and Kessler, you'll see that on the way in, 80% of the people expected to hate it. And on the way out, over 90% preferred it.
Yeah, I'll test to similar numbers. I mean, I wouldn't say they loved it, but a lot of them saw, hey, there is a lot of benefit here. I'm actually, it's making my day go a little more quickly as well. So they were more than willing to do it. I'd say I'd tell comparable numbers, maybe out of 20 developers across a couple teams, you'd still get 3 or 4 people that really hated the idea still, but the bulk of them were either accepting it or, a few of them came out of it really loving the practice.
Yeah, we introduce it to new teams all the time, and quite often we find new teams take to it immediately, especially if it's a team of newer hires. It doesn't go so well if it's an organization where there's a ranking system and the developers are in competition against each other because people can't afford to be vulnerable. They lack the psychological safety because it's important that they rank above their peers. And of course, if you were to help a peer do work, they might learn more. That would raise them in the ranking, which potentially pushes you down. So that's another one of the reasons why continuous review is difficult. It's in organizations, developers are working against each other.
Right. Unfortunately, nowadays, I mean, I think the predominance is still to not do pair programming or mob programming, also known as ensemble programming. Unfortunately, the default seems to be doing pull request, and I'm pretty convinced that the value you get out of doing these after the fact kinds of reviews, as in contrast to the active reviews of pairing or mobbing, is really pretty minimal. I think there's a lot more effort going into those and not a whole lot of return in value. I just as soon have the discussions now rather than do this back and forth thing through some kind of pull request mechanism.
And if I work alone, it's my code representing me. And then when you criticize it, so we talk about there's no editing process and no continuous review. I wrote it by myself, and you're criticizing me when you criticize my work, versus we wrote this together. And when you're criticizing your work as much as you are mine. We're talking about it together. It's our product, not me on a plate.
Mm-hmm.
Just a quick reminder to everyone in this space, if you did want to ask a question or share a thought on the topic that we're discussing right now, just feel free to submit a request to speak, and then myself or one of the other co-hosts will bring you up. In general, what do you all feel are some guidelines or things to look for in order for paired programming to be a positive experience for someone for a team or for developers who are just trying it for the first time?
Honestly, I'm going to defer that to Tim, but I mean, I'll start by saying I don't even think I would recommend pair programming as a first venture if you're going to try to figure out how to do active review and live coding like that. I would actually start with a mob, get the whole team in play, get everybody involved. And I think the dynamic is such that, first off, you don't even have to repeat things. I mean, everybody's in the room at the same time. All the information is there. With pairing, you're immediately introducing some level of overhead of managing this thing and making sure the right people are pairing with the other right people, or in other words, the wrong people aren't pairing with each other. So I think I'd start with the mob programming for step one. And there's a few rules of structure you can put around it to keep it sane, but most of that's fairly obvious. Tim, I'll let you play off of that.
I think it's right too. I think that if you've never mob programmed and you've tried to pair program, what you got was what you got. If you spend a little bit of time with, working together in a group of, 3 to 5 to 9 to 12 people, you develop the right way of conversing and the right mindset, and then pairing's very easy, and it's just a trivial version of mobbing. It's not quite as good. It's not quite as much fun. It was once told to me that if you were to think of pair programming as a date, in terms of you got two people, it's a little bit intense, you have to relate to each other closely, then mob programming is like going to a party with your friends. It's a lot less pressure. It's a lot less intense. So I find that mob programming is a good start anyway.
Oh, I'd missed the last part of that, Tim. What'd you say?
What fell down, Tim?
Ensembles are the better choice to start with.
All right. And to more directly answer the original question, we do put some structure typically around it. It's something where we're rotating people probably more frequently than one would expect. So I know John was in on some sessions we had. We actually got down to the point where the person at the keyboard listening to the rest of the ensemble or mob was rotating in and out every 2 or 3 minutes. So you'd sit there, you code, you listen, be ready to translate what people were telling you to do into the code and put that into the computer. And it was a pretty rapid rotation, which was kind of cool because it kept everybody engaged. It also meant that, first off, since you're listening, you're not having to come up with the ideas. You're just focusing on this translation, and then you get up after 2 or 3 minutes, and then if you've got ideas, you can impart them to the next person. So that starts to minimize the stress level, and the fact that it's only 2 or 3 minutes also helps. So yeah, it's basically those two core things: is this rapid rotation through drivers, as well as the notion that it's all done with what Llewellyn Falco calls strong style pairing, or what I'll call strong style navigation. In other words, the person at the keyboard's listening and translating. They're not deciding where we're going to be driving for the course of this coding adventure.
There's an article at the Industrial Logic blog. I keep saying an Industrial Logic blog article that we have about the problems, the smells of pair programming, the rules you want to have when mob programming or pair programming. And I know that one of our mentors, Anthony Shimana, also has an article on, the principles, rules, smells of pair programming. And maybe we can get those, linked in here somewhere.
Yeah, I can actually post. I'm actually posting a few tweets on top of the space and also commenting underneath the space as well. So you guys can look at those links and reach out to those blogs that Tim is mentioning.
One of the next ones in the list is insufficient technical knowledge. And I think that this is maybe getting worse. Once upon a time, you were a C programmer and you were a C programmer for 7 years. And these days, you were a JavaScript programmer 2 months ago, you're a TypeScript programmer this month, but you're also starting to get into Clojure or F Sharp. And by the way, you're also having to do Python because that's where the back end is. And by the way, the Python calls into some Lambda stuff. And you also need to know the language that, is YAML modified that's for the CI server and the CD system. You're changing languages all the time. So you don't have a very super deep level of knowledge about the stack in one part of the system. You need to have, a lot of agility to go between languages and paradigms and systems. So it's hard to have enough technical knowledge. A C programmer would know the entire standard library, top to bottom. Well, you don't anymore. It's huge. It keeps changing. And also, now you're dealing with 8 languages. You don't know every bit of every library for every language.
Well, and I think there's a trade-off too. In other words, for all that knowledge you have to accumulate about the tools and languages and such, I think that's easy enough to find on the internet, right? I mean, you can go poke around and figure out, how do I do this with thunks and redux or something like that. And you'll find a short article that answers your question. But I think we've moved in an era where we don't sit down and read thorough treatises of things like design. Design is kind of a fuzzy topic nowadays. And I think some folks have tried to simplify to the point of oversimplification and missing some of the key points. So yeah, we don't. If you go look at the book sales, I mean, I've been tracking with what Prague sells, and they pretty much will tell you their sales have dropped dramatically in the past 10 years. So we're not buying these things that'll give us this holistic picture of how to best to put together a system. We're great at learning the technologies, and those are moving really fast. But all these wonderful little design nuggets that we gathered over the past 70 years of software development, most of that's still valid. Most of those ideas are still good things to pick up. So I'm hoping to see maybe more of that come as part of wanting to work together as a team and a mob.
And a lot of people, there's a really funny element. Programmers are way too conscientious, and they're also under too much surveillance. So you have a strong conscience and you have surveillance. They feel guilty for the time they spend not typing code. And that is an interesting problem because 11/12 of our work is really thinking. We're reading, studying, understanding, trying things, undoing, redoing, refactoring, reworking, whatever. So when you're under time pressure and you feel like you're under surveillance and you feel like it's your job to be writing this new code and you're a conscientious person, then going out and looking things up. If you spent 2 minutes to get something, you copy the example in, you get it running, good. Ditch it and move on. Got to keep going, got to keep moving, right? Whereas if you were to spend 5 or 10 minutes to understand that code example in a deep way, to get a handle on the library, so different way you could have written that code, or clearly you like you've wasted your employer's money because you don't value the learning at the same level that you value the typing of new code.
I have a couple of thoughts.
Well, if you're learning, that means you don't know what you're doing, right? You shouldn't be learning on the job, right?
Yes. I've seen people chastised for that, and for like, well, you should have known this already. You've actually had a manager say, "Yeah, you've been working for 11 years." He had the audacity to say, "Hey, I've learned more in the past couple of months working with these folks, Jeff, than I've learned in the past couple of years." And he actually got chewed out for that. It's like, no, you should have already known all this. Like, really?
And what's really funny is, most of the things we do today didn't exist 4 years ago. You think, it's embarrassing to be seen learning, but everything is new all the time.
Well, okay, you're allowed to learn, but do that on your own time on the weekend. That's not the work.
That's right. Do it after hours. We shouldn't have to pay for you to learn how to do the job that we pay you to do somehow.
Yeah.
John Kern, did you have some thoughts?
Yeah. Can you hear me okay?
Yes.
Yes.
Okay. Because I'm in some low bandwidth area in Rome. So I was wondering what you thought about, I guess, two things that sort of sprung to mind. One was around some of the techniques that I tend to promote is having not only a foundational understanding about the domain, so that people understand what we're working in. This is for a long running app. That's kind of what my frame of the discussion, and also a very consistent way to construct the features on top of it. Like it in general, it's not asking developers to do things novel about how to surface another one of dozens of features that are pretty similar. Use their coding skills to work in the way that we've agreed to. So I wonder if does some of the bad code come because the foundations you think you're hinting at it with design, architecture, consistent coding styles and practices. I wonder if that's where some of the bad code can come from because people are freestyling in a system where they maybe should be coding more like their neighbor. I don't know what you thought about that.
Yeah, I think we kind of covered that. I mean, so there's an article associated with this talk, and I'm going to suggest everybody go back and spend a few minutes reading it. So I think we kind of lump that one under insufficient technical knowledge in that, part of that is understanding what's the best approach in set of practices for doing stuff like that. Certainly, we're all believers that having good amount of tests, both at the unit level and higher levels, is going to help pay off things so that you can safely start to piece this system apart and understand what it does, as well as be able to add new stuff into the mix without breaking it. Was that kind of what you're getting at, or?
Yeah, and I think basically the creativity that I want developers to employ is I would say it more at the edge at making the feature awesome. Therefore,
Gotcha.
Following the design that the team has already determined. So, yeah, I don't know. I'm just trying to think from my own experiences. Sure, I can write shitty code as well as the next person, but I think a lot of it is, too much. I don't know. I don't want to say freedom, but potentially too much, too little consistency enforced by this is how we code for this app, this language, this tech stack, whether it's YAML all the way to as Tim was pointing out, all the different technologies. Like I sort of abhor the idea that there's front end and back end code. Like that just I couldn't fathom being on a team where I couldn't do the full stack. Like teach me. There's got to be a pattern. So anyway, that's kind of what I'm talking about is it a lack of consistency and a lack of understanding that we should construct things in a common way?
Got it. Yeah. Okay. And certainly the comments I made earlier about design are relevant here. Having a solid foundation as opposed to, I absolutely believe a lot of the more modern devs coming in without proper founding are more like, oh, well, I'm smart enough. I figured out how to do this best on my own. That's my design perspective in my head. But I think I can't oversell mob programming enough because I think both from the stance of making sure everybody's on board with how is the system designed, how are we supposed to be extending it without going off into new unnecessary avenues for how to solve problems. That certainly helps with mob programming. Certainly helps with that. The other thing is, I think it helps spark creativity. And 20 some years ago, I thought I wanted to write television sitcoms And I thought, well, I'm a writer. I can write from home and just send the scripts in and get some feedback. But what I found out is the best and funniest stuff came from basically ensembles of folks working and bouncing ideas off of each other. So these kind of sparks of brilliance and humor and intuition, all that stuff came out of the absolute act of working together collaboratively. And I think in the mobs that I've seen where we've been doing more interesting things with a little bit of opportunity for experimenting, some of the coolest things I've ever seen have come out of that ability to bounce ideas off of the rest of your team.
That's wild. I mean, imagine a producer walking into the writer's room on SNL and saying, "What are you guys doing, horsing around? I will pay you to sit around a table and make jokes."
Well,
Yeah,
I,
pretty
I
much.
think that
So
there's another piece with that, though, right? And that is that most of our organizations are absolutely horrible about onboarding. Jeff, I remember once, and I don't want to bring back a painful memory, but you had taken a job and they basically gave you the code base and they said, go to it. No orientation, no introduction, no, here's what our design and architecture is. It was just go. Here it is. It's yours. You're a programmer. You should be producing code already.
Well, typically there were manuals on the wall that we had to read, and then I would fall asleep during reading the manuals. So that never worked out too well for me.
Yeah. So with the poor onboarding, people are, you're given a thing to do. You don't know how to do it. And if you remember, one of our mutual bosses, hold on. Yeah. A mutual prior boss that we had used to say that the best indicator of what your day is going to be like as a programmer is the quality of the code you start with in the morning, right? So if you're going to walk in and you've already got bad code, it's already rough, and you don't know your way around the system, and you're under pressure to produce. By the way, one of the next items is time pressure. So you're under pressure to produce in an alien system and you don't know your way around, you're going to start inventing things. You're going to do it the way you know from wherever you worked before, or whatever you see, as an example in Stack Overflow.
Yeah, fall back to bad habits. By the way, if you're interested in actually seeing a slice of the collaborative humor in action, there's something called 6 Days of South Park, which kind of reveals the process in them making it. And they absolutely do a team room kind of a thing where they're bouncing ideas against each other. And it's an entertaining watch.
So it's funny, we tuned in to hear about where bad code comes from, but we keep talking about all this mushy human stuff.
Yeah, and that's something. Well, I mean, the first thing is humans have to be able to read this nonsense. Back to my definition of bad code is it's the first stuff that you slap out of your keyboard and put onto the screen is probably pretty bad code. So which is maybe a segue to one of the next thoughts on where this bad code comes from, which is needs to be edited. Just like any writer puts prose down on paper, then comes back and starts making the words a little more happy to everybody. We have to do the same thing. And the sad part is most of us don't. Most of us are like, okay, let's get the code out there, demonstrate that it's working, and then we're not going to touch it. Because by God, if we touch it, there's a pretty good likelihood that we've broken something and maybe don't even know that we just broke something. So unfortunately for too many developers, there is no built-in kind of editing habit or editing process that we might get out of doing something like test-driven development. This is absolutely one of my big things I harp on. We just need a way to make sure that once we put the code in place and gotten it working, we need to come back and make sure that everybody else understands what that code's intent is if it's not clear.
Well, this also
Things
comes
about
back
TDD
to
is you get a test that's red, you want to make it turn green. Well, you're just going to write whatever will make that do that. And that's the right thing to do. You just make it green. Hold on. We had a lot of noise. I could see it coming. So you do the right thing. You're red, you go green, and once it goes green, you look at the code and you say, okay, well, let's change this to make it look like we always knew what we were doing. We understood it from the beginning, and we planned it from the start, right? So there is that editing cycle where you go from red to green, and then green you go into refactoring, and you make it look, you incorporate it gracefully, you make it readable, you make it good for your audience, you make it clear, simple, small. And then, you commit that and move on to the next one. A lot of people don't follow a process that allows for constantly evaluating and reworking the design to keep it up. So they end up with something where their original version, however naive, was written, and it was very clean and pretty. And then they've patched around it with if statements for years until the actual original design is the only thing it doesn't do anymore. Oh, there's also, by the way, someone was posting an article, and it's been in the last week. I'm going to have to find it. And they're finding that the broken windows theory actually is true for software. That if you pick up a piece of software and it's already kind of bad, you will tend to make it worse instead of clean it up. And I'm going to try to find that study and link it, but it was within the past week or so. So it's a new study.
Yeah, and I always look at warnings as a really good indicator of how people really don't give a hoot about a lot of little things, particularly once there's 1,000 or so of them. If you see 1,000 in some warnings, you can guarantee there's going to be 1,000 in some plus one in the next few minutes because nobody's looking at those numbers. Nobody cares to squash them. So yeah, I firmly believe a study would support that in code.
Yeah, looking at an already bad code base, you feel like you're going to be nibbled to death by ducks.
That's
Ducks?
painful.
You're in Scotland, right? They have ducks living around you out there, right?
Yeah, and apparently right now all of the swans have been emancipated, unfortunately.
So I have a radical thought.
I would like to take a moment to so we are actually going towards the end of this space in like 20 minutes. We might extend it based on interest from the people and availability of our speakers. But I would really like to get some feedback and input from the audience as well. And I see a few new speakers on the panel. So Kevin, you have joined us. Please go ahead and contribute. Thank you. Kevin, are you there with us?
Yeah, sorry, I think I lost my connection for a second. Can you hear me okay?
Yeah, you're doing fine. Go ahead.
Cool. So I saw that Troy had tweeted a question, and I just wanted to throw it out to the group here. He asked, how could we measure the cost of bad code, or if we sort of flip it around, how can we measure the value of good code? And I thought that was just we talked about how this is often organizational problems and connections between people, and I'm just curious, how have you all measured that in the past, and what?
I mean, the problem is the end result is there's no way to quantify those numbers. And if you start thinking about just the myriad costs of bad code, from starting with the fact that it's going to take you longer to understand, to the fact that if bad code tends to foster more defects. And what's the real cost of a defect? It's huge for any defect because you've got support calls involved, you've got rework involved, retesting involved, shipping it, lost customer time, and so on. So I mean, there's just so many myriad little tiny costs that nobody ever bothers to do accounting for when you start creating bad code. But I'm going to start with the fact that just I'm sure everybody here can remember a time where they picked up code, and it's something that probably might have been something that might have taken 5 minutes to understand, but instead you found yourself wading through it for half hour, 2 hours, 3 hours. I found myself in plenty of cases where I had to spend a whole afternoon trying to figure out what a complex 200 line long function was doing in order to be able to understand it to make a change. And we never account for those kinds of times. It comes out in the overall rate at which we deliver software end to end, but even that doesn't account for the interruptions that come later when the code comes back with problems. So I don't even know how you begin to start to measure the true cost of bad code.
There have been people trying to do that and to measure different kinds of badness. The trouble is, again, there's a negative space, right? So if I had a good way to measure the good code, then we could say, oh, when these numbers diminish. There are a couple of measures that are better than others. Nothing's great yet. I think the best one I've seen in some time is by G. Ann Campbell, called Cognitive Complexity. She works for Sonar Source. There's a video about that. It's quite nice. She explains why it is what it is. It is heuristic also. I mean, it's not, there's no sure thing. But if you think about it, I've gone around to companies and I asked them how much of your development effort goes into defects. And we're finding that in most corporate shops, 60 to 80% of their time goes to defects. So you think about that, 40 down to 20% of their time is on new features. If you could write code so that you had a lower likelihood of creating defects and in such a way that you are more likely to detect them before it ever leaves your desktop or laptop, then think about that. If you were only at 60% defects, right? If you could take twice as long writing your code and have no error come back, you would be 20% faster going to market. And that's going twice as slow writing the code, being twice as careful.
Hey, Tim, there's something wrong with your microphone. Can you fix that?
Oh, no. Let me find another place to stand. I'm in a hotel with poor Wi-Fi.
I think we can hear you fine, but it's like, yeah, go ahead, John.
Yeah, we could hear you. It just got thin.
Okay. How's it now?
Still thin.
Still thin. How's it now?
A little better.
How's it now?
Not so good.
Yeah, I can't tell. So let me know if I fixed it.
Nope.
Oh, boogers. Okay. Well, I do recommend, take a look at cognitive complexity. Think about the cycle time problems you get when you have you've got your code that's bounced back and forth between PRs and code reviews and QA. Maybe it bounces back from the security group. Every time that comes back, you're going to be repeating queues and waits. So I would say that you should get a loss of defects, and you should actually be able to put things to the street sooner, and that should be measurable. But as far as, again, directly measuring the code, there's cognitive complexity. There's certain compound grades you can get from things like Sonar Source. But you can't just rely on that. You need an audience reading the code and saying, yes, this is very acceptable. This is good, clear, obvious code. And this has to be an audience who could say, even to a senior programmer, that's just too fancy, or that's just too dumb, right? It's too low a level of intelligence. It's doing everything the hardest possible way. We can raise that up a little bit.
So
Awesome.
once you identify code is bad, like where do you start to try to fix it? Or do you try to fix it? Like what do you usually look for, I guess, as a place to start?
Well, right. I mean, that goes toward the first notion of you have to be able to understand the code in order to be able to change it. So we certainly prefer code that was test driven, written the test first because it's a matter of setting out some expected outcome and then writing the code that meets that outcome, which to me just makes so much more sense. And then you have these wonderful tests that document essentially what the code does. If those tests aren't in place, we'll sit and spend some time writing characterization tests, and that starts to afford us the ability to incrementally make improvements to the code. So my first job is, like I said, I've got to understand what the code does. I'll do as much automated refactoring or real simple things that aren't likely to break anything. Then I'll start adding tests to make sure that I fully understand what is the collected set of behaviors in this method. That to me, without that ability to clamp down on what the code does, you really can't touch it. And if you can't touch it, you're always going to be revisiting the same chunk of code. And so are other people on the team and so on. Every time you look at it, you're going to spend inordinate extra time wasting time trying to figure out what's going on in the code. So that to me seems to be step one, is characterize it so you know what it has to do, so that if you do make changes to it, you know the moment that something is no longer working.
Let me give you a step zero on that though too, because this is obviously an investment, right? So for the sake of being frugal and productive, I would say step 0 is that you look at the code and remember that we're going to refactor the code that impedes us, not just the code that offends us. When you're in the throes of trying to, produce a new feature or a new system, it's the things that slow you down you need to fix. And you may see there's some file and it just stinks and it's icky and it's gross and you don't want to touch it, but you don't have to. Leave it alone. Leave it alone for now. Just do the things that impede you, that slow you from getting your results. Clean those up as you go.
Yeah, exactly. And honestly, once you do have the ability to start making a few changes, it's actually not too tough. I mean, it's work. It's much slower than had you done it right in the first place. But still, renaming things goes a long way. Doing a little bit of extraction and method goes a long way to create new abstractions that kind of hide some level of ugly detail that you don't need to change. So there's all sorts of wonderful techniques. Michael Feather's Legacy Codebook is still the go-to on this. Plenty of safe ways to start approaching this very incrementally. It takes time, but if you're going to keep this code base around, like pretty much every code base ever does, it sticks around for years or decades. It's absolutely worth putting a stake in the ground and saying, look, from here on out, we're going to start doing the right thing. We're going to start making sure we write the tests. And as we do, we can start making the world a little better place to live in when working in the code. It'll eventually get there.
What's really fun about that is it's actually pleasant to do.
Yeah, it's
So one of the reasons that you describe in your blog is time pressure, and we have seen it again and again in organizations undergoing transformation. We hear it again and again from managers that uh, they would be putting pressure of deadlines, and that is how the organization kind of incentivize as well. So the goal of improvement is not prioritized.
Right. And we know better. I mean, we've seen this for what? I've seen this for 40 years plus, and a lot of the problem is that we haven't got the basic idea at a product management or project management level either of the idea that you should slice, not squeeze. If you've got 2 months to get a job done, you try to squeeze a 3-month job, slice off the best 2-month piece of that you can. If you've got a week to get something done, you don't try to do a 5-week job in a week. You just try to slice it down and do a week's worth of work. Or maybe if you're really feeling clever, try to do 4 days worth of work. But that's the thing, is people are insisting that the way to get progress is to squeeze harder. Squeezing never works.
Cutting corners doesn't work either. I think we learned in the 80s and even earlier that quality pays for itself. We've seen managers who basically said, you know what, you need to jettison this whole refactoring stuff. Don't worry about keeping the code clean. You need to jettison the test. Don't worry about the code review and so on. So all these quality measures, you start throwing them out. Yeah, you might get the next delivery out a little sooner, but I can guarantee you're going to start paying for that. It's going to be much more costly in the long run to jettison any kind of quality controls. So, I mean, I think, honestly, sometimes the people who are worst at putting pressure on us are our very selves who think, well, we better just kind of rush through this and get to the next thing. So I think we pressure ourselves way too much as well.
But you won't necessarily fail that way. And that's what's really weird is, software and most of us work in fairly lucrative businesses. I'm working with people who are, their company makes so many millions a month. Well, if you've got a big enough margin, then the losses from having terrible code and programmers struggling every day and bugs and delays, that's all down in the noise. That's the amount you would lose in the couch, right? So organizations with a big margin can afford to be woefully inefficient and to impede their own progress and to have terrible code and keep running. That doesn't make it fun, but it's an interesting thing to remember. You may not fail, no matter how bad it is. You might not fail, you just might suffer.
All right, we have a couple of new speakers on the panel, so let's include them. And then there's a few questions on the in the comments as well, and I would like to take them upon as well. Manish, you're on the speaker. Thank you for joining us, and go ahead and add your comments.
Thank you, everyone. It has been wonderful listening to all the point of views. I have a question regarding early internship and early careers. I have rolled out a program for college students for early internship where they can come up and work on existing product and maybe create their own prototypes and stuff like that. And I was wondering if mob programming would help them, especially basically they would be remote, virtual, distributed. None of them might meet as an office. So, what's your advice on if it is even applicable and how to go about it to make this journey smoother for the interns and not only give them the learning experience, rich experience, but also they should be able to create stuff with that.
So I'm going to quickly give an answer because I just wanted to sell mob programming one more time. When COVID started, we were mob programming at one large automobile manufacturer in the U.S. And then we all got sent home, and most of the company freaked out. But basically, we started doing remote mob programming, and it end of the first day people were a little frustrated at what was going on, but second day they're like, okay, this is still a lot of fun, we're still pretty effective by doing this remotely. So I think it sounded like you were trying to get some notion of supporting distributed internships and whatnot. I think one of the worst things that we do to new folks in this field is leave them to their own devices. So if we can start pulling them in and collaborating with them day one, they can actually start contributing day two. So if we get everybody working online as a cohesive team, sharing ideas, thoughts, and bouncing things off of one another, they're going to advance so much more rapidly than they would if they were each in their own home distributed around the world. So that's my last pitch for mob programming for the day.
I'll throw in with it. I don't know a better way to become familiar with the code base than working with the people who know it. It's unique, and there's no better way to get to know a domain than to work with the people who know it. And we just tend to think somehow or other that there's a virtue in people going it alone. But I think if I remember correctly, the numbers they were giving for HR was that a new programmer took between 4 and 8 months to come up to speed.
Oh.
And then they said with mob programming, that tended to be weeks.
So just a brief story on that. Tim, you visited one place I was working back in the late 2000s, and they said they took 3 years before they trusted a developer alone on their systems because they were very touchy systems. And if you take the system down, it's one of these, oh, we're losing $1 million every few seconds things. So they didn't trust people for 3 years. And then they realized they were hiring all sorts of people from one place overseas. And it turned out that their average turnover was about 8 months. So I don't think that's ever going to work out, is it?
That sounds like a risky system. You need 3 years and you get 8 months.
Pretty much. Bad trade-off.
Well, I mean, the obvious answer is to just not let them code alone on it.
Yeah.
Like ever. Just keep going.
I
wanted to throw in on Manish's question. I actually ran an academy of almost exactly like the situation he's talking about for folks straight out of college just getting into their first professional programming situation. I ran a program like that for 8 years. Most of that time, we used mob programming as kind of the setting for the teaching. And the one thing that hasn't been mentioned about mob programming, it's excellent for learning. And the thing is that it actually benefits. Usually when you're teaching, you want the folks that you're teaching, the group that you're teaching, to have a similar level of experience. Like you're going to do a beginner program and maybe an intermediate program and an advanced. And you want to keep those separate because you don't want people slowing each other down. But mob programming as a learning environment actually benefits from a wider range of experience because the folks with more experience collaboratively end up teaching the folks with less experience, and there's this kind of synergy, a simple symbiosis that you don't get in a traditional education setting.
I've been putting together ensembles that involve programmers and non-programmers, and we had a non-programmer the other day saying, "Yeah, I'm sorry, guys, I just don't know much about coding. It slows things down." And the programmers in the group were like, "No, man, no. You're asking questions it never would have dawned on us to ask." And that has really improved our code. You've been contributing. So a lot of times people, don't understand. It's actually all the diversity, not just levels of experience, but all the things you can bring with new eyes to the group. The group takes advantage of that.
Well, my other question would be, and I was thinking earlier, there's a mob programming. People would jump in, right? And it makes it, do you think it makes it more difficult to do contribution attribution? Like at the end of the day, traditional management would say, "What did you achieve?" And they would say, "What? I contributed to the mob." So,
Yeah. Yes. In fact, I would say that in a team that's working as a team, it is impossible to separate the work of the individual from the work of the team. I would say that it's not hard. I would say it's absolutely impossible.
Yeah, I mean, to me, this is where some misguided abuse of practices that people think have to be there in Agile, like daily stand-ups, really bug me. It is more about like, what did I do today? Well, no, it's not really about what you did today. What did you deliver today of value to the customer? I mean, in a good mob where you're clicking and working at a good pace with experience, a team that's experienced with each other, you really do seek this goal of what can we actually ship to the end customers today in many environments where that sort of thing's possible. And that's the discussion. What did we ship to the customer of value? Not what did I do, not what did that person do. So yeah, the whole individual attribution thing to me starts to become kind of silly in that sort of environment.
Yeah, in most cases, individual attribution is a kind of ranking, and it's done for the purpose of ranking because people are convinced that we should know who the good one is and we should know who the bad one is because there are good ones and bad ones in our company. It's like, well, why did you hire bad ones?
And there's always people there. I mean, and we know who they are. I mean, I think that's the important things. We try to help the ones who aren't up to snuff, and they do come up more rapidly as long as they're willing to, spend the investment to improve themselves. In a mob, it becomes obvious, and I'd say we did a lot of work with this one company for the past 3 years, and I'm going to say the bulk of people actually improved dramatically as a result of being able to have this one-on-one or one-on group interaction every day throughout their early development careers. And there was probably, I'm going to say, 4 or 5 over the course of those 2-3 years that just you could tell that it was never going to work for them. So they found their way to other things. So certainly it's not for everybody, but the bulk of the people, it's going to improve them and their team around them as well.
Jeff, one last question. I know I've taken a lot of time. Apologies for that. But you have done mob programming with college students, maybe the early in kind of an internship that I was talking about. What were top 2, 3, maybe the challenges that you have faced, the difficulties that could help me avoid that?
Difficulties around just the mechanics of doing things or the interaction, or what kind of?
Yeah, overall, like when you started with a fresh mob, and then what difficulties or challenges you faced, and maybe how you overcame it. It could be anything. It could be technical. It could be non-technical.
It's usually the non-technical, as I think John Fazzaro was hinting earlier, that it's a people problem. So usually our challenges are with individuals and their attitude towards things or each other.
Jeff, I can specifically say that the challenge with folks fresh out of college and getting into a learning environment, collaborating, is they're terrified of giving the wrong answer. And they all feel like they're imposters. They have terrible imposter syndrome. And I remember having to have the same conversation in many one-on-ones, just talking them through it. Hey, just say you don't know stuff. Yep. And once they got that, then the wheels were pretty well greased.
Yeah, I have 40 years of doing this, and I still have imposter syndrome, and I still have fears about speaking up and whatnot. But yeah, I mean, the first day of engaging in a mob is actually pretty rough. The second day is a little better, and the third day you start seeing all these light bulbs turn on as people start realizing they don't have to be afraid of not having the answers all the time. And I'm going to say critical to that is back to this notion of a strong navigator, such that we're not really putting people on the spot. No, our job is to help each other come up with the better solution. So it's actually, if structured well, it's not this free for all, and it's not one person being pinpointed to have all the solutions. It is a true collaborative thing where we are looking to bolster each other's knowledge, and it very quickly people get the picture. It's like, oh yeah, this is a lot of fun. I've seen people go from terrified day one, and week later they were championing the whole process.
It is amazing how much people will assist and collaborate and work together once you remove the sense that they're competing against each other and that they need to win. I've actually seen some pretty bad sessions where somebody tried to win the mobbing session. And that's a time to go take a walk outside for a long talk.
Is that called parking lot therapy, Tim?
Yeah, parking lot therapy. Which is much better than some of the other kinds of therapy that are available.
Oh, old school parking lot. Yeah. No, I can't do that anymore. Kicked out to too many companies.
Parking lot therapy is okay, I guess. Certainly a long walk and talk in the parking lot used to be the way to go, but now we're all virtual, so it tends to be a private Zoom for a half an hour. By the way, one time we had this, and the person really felt like they needed to win all the programming sessions. So in the middle of a session, I asked this person, "Would you like to take a walk with me?" And he was like, "Sure." And we walked out, and we got a coffee, and we walked around the lake, and we just chatted. And I said, "Listen, I just wanted to see what would happen, what they would do without you leading them, and see what that looks like." And he said, "Oh, all right." And when we came back, they had done wonderful things. They just needed to have 45 minutes without being told to.
Which, yeah, I mean, that's a trust thing, right? I mean, one of the best things you do by building a team, is try to get them to learn how to trust each other. And if you've got that, you probably have a winning team.
Yeah, and of course, that's very hard if they are, and they know they are being ranked against each other, because then you do have to win.
So there's a related question that somebody asked. Actually, Jimmy from the audience, he commented and he said, "How would you approach a difference in opinion among a group on the quality of the code/fix?"
Oh, we do this all the time. Usually, what we do is we have them write it both ways, and the group decides which one they like.
Right.
That's
That
the
way,
easiest way.
it's no longer, it becomes less theoretical and arguing, and it's more, well, let's see what it looks like. Let's actually try it.
Yeah. Yeah, that was the rule. I mean, we usually have what we call 10-minute rule is you argue for at most 10 minutes or even 5 minutes. You can set that down further. And at the end of the 5 minutes, one person says, well, here, let me show what I got. And you take a look.
In the article on the blog, again, back to the blog, that it refers to that as argue in code, not about code.
Oh, that is in here, isn't it?
Yeah, it's in. I think it's in ours too, but it's also in the blog article about mob programming tips. I remember it's a picture of two architects, or blacksmiths arguing over a blueprint. So if you scroll in the article and see that, it's the right article. There's another thing called the hamburger game, but I haven't written it up. I've taught it a lot of times, but it's about 10 minutes longer than we have to describe. But if you remind me, I will write an article about the hamburger game and share it, and then we can see that one also. It's quite a useful technique.
Awesome.
Jeff, you want to write it with me?
I'm sorry. Sure. Yeah. I got another one I'm in the middle of. You're going to have to help me with.
Okay. When we finish this one, we'll do that one.
Okay.
I volunteer as tribute for the hamburger game. That sounds delicious.
It is yummy. So yeah, I mean, Tim and I actually write collaboratively as well. It's not just I'll go write my piece and he writes his. It's this kind of cool little live Google Docking sort of thing where we're actively changing each other's prose at a whim, and we never get upset with each other. Well, maybe once.
Well, yeah, I don't remember being upset, but I'm always worried that we will be. But it never seems to work out that way. Changing the code, I type a sentence and he's editing the sentence that I just typed, and then I go down, I'm editing one of his paragraphs, and he comes in and edits my edits while I edit his edits of my edits. It's kind of you think it would be like a conflict, but it's really not. Oh yeah, I like that better. Thanks.
Yeah, I mean, it is trying to come to a voice that means something to everybody involved with the writing. I mean, the same thing with the code base is it's got to make sense to everybody in there. I mean, that's the beauty of the mob programming is everybody gets to see what's going into the system. And if they have a problem with the way it's phrased, it doesn't make sense to them or makes it really hard to understand, they can speak up at that moment and say, well, nope, not going any further until this gets cleaned up.
Yeah, and that also reminds us that it's not what we wanted to say. Readability is a relationship between the artifact and its audience.
Okay, so we have Bruno on the speaker panel. Welcome, Bruno. And okay, he just went to the listeners. I think it was too late calling him on the speaker. All right, so we have actually gone past 9 minutes over the designated time for the space. Would you guys be able to continue for a little bit longer, or do you think this is a good time to say goodbyes?
Probably a good time to wrap up. I mean, I'm available, but probably should let folks go for their Friday afternoons or evenings.
Absolutely.
Come back for more.
Yeah,
what's
we do
next
this
week?
every Friday.
What's next week?
Next week, we have one of our IEL coaches, Tim Barry. He's going to be, we're going to be reviewing his blog post around user stories and stuff. So we'll be posting that sometime on Tuesday next week. So stay tuned for that. We schedule our spaces early on on Monday or Tuesday, and then we share it through the Industrial Logic Twitter handle, and make sure that you guys are following the Industrial Logic Twitter handle to find out what spaces we are coming up with. And this is a recorded session, so after this is over, the recording will be available for you guys to replay and share with with everybody.
I've been sharing Tim Batty's article multiple times with different people, and I think I posted it on Twitter 4 or 5 times in the past, I don't know how many weeks. So that is definitely not one to miss. If you have anything to do with user stories at all, you will deepen your understanding from what Tim has to say.
Awesome. So Jay, wrap us up, please. Thank you.
Oh, yeah, no worries. I was going to say thanks to Tim and Jeff for leading the discussion today. Thanks to everyone who submitted a question or joined the stage to ask a question and contributing to the conversation. Again, doing this every Friday from 3 to 4 p.m. Eastern Time. Everyone have a good and safe weekend, and we will see you next week. Thank you.
Thanks for having us.
Bye, everyone.
Thank you.
Thank you.